Hello, everyone. I think we have everyone here already. My name is Oleg. I'm a developer in SRE. Depends on the weather. I switch from one side to another. And I just really want to tell you very basic stuff, really. I hope everyone will understand what I'm talking about. It's not going to be rocket science. It's just my personal pain I want to share with you. I've been having these debates with mostly developers, not SREs, about how to properly initialize their applications. And I just decided to formulate it all together so that it's just in one place. I expect this talk to be pretty reasonable and relatable for most SREs, but it might be debatable for some developers. And I hope that after this talk, you will be able to send it to some people that you want to convince in this opinion, or we might also talk about it and have an argument if you want. What are we talking about? I will start with a motivating example. Let's say you come into a new company, you start a new role, and you're given an application to support and maintain and deploy and everything. But the config for this application looked like this, and you just start looking at it. Something is just wrong, not just about XML, but even the contents of the config itself is just questionable, and the developer that probably built this and made the first version of the config just made very questionable decisions, right? And you just start looking into this, and you have endpoints, and you have weird amount of nesting inside of config, and you have just weird values, and just look at this, and it doesn't make much sense to you. You decide to deal with this and go through why it happened like that, to the history of this config. And we'll try to address all the problems formulated and maybe find a better solution together. So what is a config file? What are we going to talk about in general in this presentation, in this talk? The config file I'm going to refer to is just this static part that is being consumed, being swallowed by your binary on the start of your service. Binary or any executable, really. So it's static and it doesn't change at runtime. It's the way to change your config is just to restart the application. Very simple stuff. Why people use config files? Mostly because it's just in one place. It's very convenient. You just open it and you see every configuration of your application in one place, except for the config flag, because you actually need to point to the place where the config is located. So it's not complete true, but still. And it's easy to write for local testing. And this is the argument I hear mostly. You just write a single config file once, and you just start your application with this config file when you're doing this manual local testing with your application. And it allows for nesting for these config subsections, which is sometimes it's very important. And this is the true real argument for using config files. Sometimes it's just necessary and unavoidable. And it really allows for arbitrary config size. It really depends on your disk size or if you use some MFS for your RAM size. But config files have a lot of problems. First is obvious, it's additional indirection. We don't have just application and its config. We actually have a file that contains this config in the middle. So it brings worse observability because you don't see the whole config of your application when you just look at the run command of it. You also need to find where the file is located and you need to read it. And it has a file system dependency, which is already a thing that comes out of nowhere. It brings deployment difficulty and access management difficulty. It happened to me countless times that for some reason, something was misconfigured and the config file was just not even readable by a person. So the SRE or DevOps just couldn't even read the config with which the application is starting, which is really weird. One thing I will also point out is that config files also have arbitrary format. And if you're not standardizing on it, people might just I love YAML, I love XML, I love TextProto, I love something else, JSON. And you have this zoo of different config types, and you also need to have much more cognitive flow to just understand and read all of them. And templatization and on-the-fly changes are sometimes just impossible with config files. What if you need to change some flag in your config file, one field, but your config file is not even writable, and it happens mostly in containers. And templatization in the previous talk, in one of the talks, we saw that for OpenTelemetry, for example, yes, you can evaluate some env-vars in your config, but it's very limited still. You still cannot change subsections of the config on the fly. And it's usually unschemed. So I very rarely see that people actually write a schema for their config files. It's just an arbitrary nested structure that you read, and unschemed configs bring garbage in a config. You open a config file for some old application and you you're not even sure which part of this config is actually being read in the application and what is just garbage sitting there for years and doesn't do anything. So you don't even know which part of it to change to adjust your application. Do we actually need them? Let's get back to our motivating example and try to make it slightly better. Maybe simplify it. The first part is we just see a lot of useless nesting here. Yeah, it's kind of brings more sense to the overall contents of the file, but we don't really need it. Without it, it's going to be the same. And in this particular example, we don't have that many fields to really need this nesting. The next part is some field that you don't even understand what it means. Like it's called internal. Do we really need to adjust it? You go to your developer and ask what this field actually does. And you have this 30 minutes lecture of how this field actually behaves, what it does. And you understand that you do a code search in your repos and that it never changes. It's always 11 in every single instance of your application. But the developer is very religious about it. He says that every field is required. You should always specify it, and you should not have like optional values. We just try to convince him that it's wrong and we should have reasonable defaults, but we'll get later into this. The next part of this undead config, as I mentioned, just some field that was never removed from here. It was just an experiment, I don't know, half a year ago. It does nothing, but since your config is not schemed, your application is still going to start with it like usual. We don't need it either. Next thing is more important. Endpoints is the most important configuration field because it actually specifies these services, databases, and stuff that we talk to at our application, right? And I just feel that some, mostly like developers again, they don't really know how to work with them. So they start implementing various formats and APIs to accept it. But we have URIs, we have been having it for decades, which is very standardized format for it. And yeah, let's just use it. So next thing is, let's just use some new format. We all have YAML for some reason, so let's just switch to YAML. And now let's just take a look at how we actually run this application. And the run command of our application now is almost as long as the config that we're providing. What if we just move it here, right? So simple. Now it's all in Flags. And now it's all in one place. And we can even do things like adding new flags at the end of the list of flags. Like when we want to debug something in prod, maybe we attach to one instance. I know it's not a good solution, but sometimes we actually need to do this. And with config files, it's just impossible to do. But with flags, it's so easy. So just to better formulate what is a flag, what we're going to talk about. In this case, flag is going to be a command line argument or environment variable. It's also a flag because it's basically the same thing. It has a common format, which we all know. It can be either single dash, single letter. It can be space or equals, and for envars is the only syntax that really exists. How to actually work with flags? I decided to put this part here because mostly, again, developers, they feel really stressed when working with flags, especially in C and C++ because there are no libraries to work with flags. And it's just really painful. Because for us, for SRE side, it's easy. We just provide flags and we start the application. But for developers, it causes some problems when working with them. With Golang, we just have a standard library, which is nice. If it's not enough for you, you can still use Cobra, but even the standard library is nice. For C++, the upsell flag is my favorite because it's very simple. You don't have any dependency. It's a single repo. And it actually looks the same because probably the same people were responsible for designing these libraries. So it's very, very simple. And you can read a bit more about it if you want. Again, Cobra if you need more advanced flag usage. How to work with envars. Envars cause even more stress for developers because, again, in languages like C and C++, you should not read envars after spawning threads because it's unsafe and the access to envars might not be synchronized, and there are many other issues that is related to that. So very convenient way is just put the value of your envar as the default for your flag. This way you don't really need to think of it. The envar parsing is going to be a part of flag parsing, which is just a convenient way of doing it. Why flags, you might ask? No file system dependency. The templateization goes out of the box. We can use all the power of shell if you want to access shell variables or even execute some small commands to calculate the value of the field. Since we don't have file system dependency and a different direction, we have better observability. We can just PS our command and we just see the run command, the whole config of it. And sometimes exported envar propagation. So in the example with kubeconfig, if we spawn more applications within our applications like subcommands, We don't even need to specify the config, it's just going to be propagated. Again, with files, it's not that simple. And usually, but not always, know that flags. Most flag libraries that I know, they're just not allowing you to specify flags that do not exist anywhere in the application, that are not defined in the application. The application's not going to run if you provide some flags that don't exist. It's not the case for envars, because envars work differently. That's why I think flags should be still a priority rather than envars. And now the section of arguments why I hate flags and I'm not going to use it, and we'll try to answer that. Not me, like some person I'm talking to. Right now I can write my config in a file just once. Do you expect me to start my programs by hand when using flags? Yeah, it was a real argument. The person really told me that. So my answer was, so in the prod, you're not copying config files by hand either, do you? Because if you do, you're doing something wrong anyway. And for local testing, we can always write a shell script that does exactly the same and has all the fields with a shell command within this very small script. Yes, it's not going to be a file in your favorite YAML, but it's going to be doing exactly the same stuff. So it is solvable easily. I can make nested configs with flags. Again, in 95% of cases that I meet, do you really need them? Because most configs can just be flattened, especially in the era of microservices. We don't really have huge flags in most cases for our application, we're designing them. If you still need it, some limited nesting kind of stuff is possible. We can use dicts or maps, lists, and arbitrary length strings, and a lot of CLI tools use it, and even a lot of programs like applications, the daemons use it as well. It also has unified format. But otherwise, it's a valid concern, really. Unfortunately, sometimes we do need nesting. We're going to talk about it later in this topic. But yeah, otherwise, it's a valid concern. The next thing is my favorite. Command line limit is just 4 kilobytes. My config won't fit. So again, is it really too small? Because again, era of microservices, it's probably going to be enough. But actually, it's not true. The person that told me that, I just believe them because, he was more experienced. I thought he knows about these limitations, but actually, it's not true. The limit for the shell command is on most Unix systems is argmax, which is usually around 2 megabytes. And it only applies to exec-based commands. If your application is just a shell built in for some reason, it might happen, it doesn't even have this limitation. So it's only limited by amount of the operating memory, amount of RAM. And it can be checked easily with xargs. So you see that the amount of length of the command we have here. And you can read a bit more about it. What was the 4K limit actually? It's actually a limit for the single string that goes into standard input, which is completely different from run command. And even this thing can be disabled with disabling the canonical terminal if we want. But again, we only talk about run commands. We're not talking about standard input. A little things about config files and Kubernetes. When we want to run an application that uses a config file in Kubernetes, we have two realistic options. One is baking it into a container image, which is a terrible idea in general because you're not going to be able to change it. Really not going to be able to see it in most cases unless you attach with debug container into your container. So yeah, we're not going to discuss this option. And the second one is just the option that was designed for config files is the config map, right? The first problem with config map is it's size limited. And the limitation is coming from etcd side, which is just 1 megabyte, which again, I think is fine. And it's pretty ironical because it's 2 times smaller than the run command on Linux. But it applies to all the resources, not just config maps. So it applies to your deployment on the pods as well. So your run command is not going to be bigger than 1 megabyte anyway. So it's not big of a deal. Much bigger problem with config maps is that it is an independent resource. So let's just talk about the common use case of Kubernetes in general, about deployment, about applications, how we actually orchestrate their rollouts. We have a deployment, which represents a single application in a single environment, usually. We have a replica set, which is basically just an implementation detail in Kubernetes. And we have pods. And the pod represents a single instance of a single application in a single environment. But where does our config live if we use config maps? It lives somewhere here. It's a completely independent object in Kubernetes that the deployment and pods, they know nothing about it when it changes. It brings a lot of problems. Deployment doesn't know when config map changes, so there are no progressive rollouts when you change the config. What your pod is actually expected to do is expected to implement some iNotify-based logic to watch for file changes and do this internal restart without restarting the binary. But how often do you actually implement this feature in application? I don't think it happens very often. And if you do implement this feature in your application, it means that the config change propagates everywhere at the same time. So we, again, don't have a progressive rollout, which is, yeah. And again, the opposite issue is that now it's impossible to make binary plus config releases while breaking backwards compatibility. Very often you have a new version of the binary and you want to deploy it to the new version of the config. But if you're using config maps like this, your old version of the binary, old pod, during the restart, might start using the new config, and it might just enter the restart loop because it doesn't know how to work with the new config, because it has some fields that it doesn't know how to parse. So it just brings so many issues. One of the solutions for config maps that I know is we need some release control with pruning. We all use Argo CD, and we have to manually, externally version our config maps by placing the version in the name. You can also use some other tricks with envvars, but it's basically all the same. You have to make version of your config map to make it properly work. Now, when you deploy a new version of your application, of your binary together with your config, the old binary is the old pod's gonna still use old config map, the new pod's gonna use new config map. It's great. But now it's inconsistent because we don't do this for deployments, because deployments are smart. They look for changes. They know how to amend the changes. They know how to restart the pods. But config maps, they're not that smart. So it's gonna be inconsistent. Deployments not gonna have a version in the name. Config map is gonna have a version in the name. What about flags in Kubernetes? It's a native way, and Kubernetes uses them all the time. It's a part of the deployment, and it's just bound to pods, right? So every time you change your flags or envvars, deployment will see that you made a change. It will progressively roll out the new versions of the pod. It will progressively downscale the older. One nice feature of flags in Kubernetes is that it can refer to envvars with this simple syntax, and envvars in its turn can refer to metadata of the Kubernetes. So you can read the actual pod IPs in flags, and you can provide it into envvar, and then envvar can be provided to flags. I don't know why you cannot do this with flags directly, but again, very nice thing. And like generating config map on the fly that has this metadata inside of it, it's also very difficult, right? But still, sometimes we really need config files. Sometimes it's just unavoidable. A few tips on how and when to use config files. When it's like really large and reading flags or just providing flags is just not going to be feasible. And when you need nesting. One example is third-party applications like Nginx or OpenTelemetry or anything like that. You just have to use config files because it's just a better option realistically. But if you do need to use config files, I strongly recommend to use a skimmed format. One of my favorite is actually TextProto because, it's like a protobuf written in the text format, and it's very convenient to just parse it with a single line of code, like parse from TextProto, and you have this single protobuf object that contains the whole configuration you need. I do not recommend using it if you don't have gRPC or protobuf in your project. Of course, in this case, just use some other format. But if you already have protobuf dependency, it's worth trying. How to use flags? I would say just use them everywhere as much as possible by default. But still, if it's very big, if the config is huge, still prefer to use config files. If you use flags, standardized flag libraries per language. Do not use different flag libraries for different things because, it's going to create inconsistency again. And some general advice on configuration in general. Always think of reasonable defaults. So this is actually a topic that might need a different lecture, to be honest, different speak, because I heard this opinion that every configuration should be required. You should never have optional fields and everything because it's explicit. It was the argument that everything required is better because it's explicit. But my answer to this is, let's suppose that we have the situation, we are moving into a new house, and the architect or the builders of this house, they decided to not configure your power sockets. And you actually need to change the voltage manually because the person decided it's so convenient when you need to explicitly specify the voltage of your power outlet. So you'd have to calibrate it yourself, go to every socket and change the voltage to 220 volts yourself. So this is what I think about this argument of everything should be required. No, everything actually should be optional in my opinion. And realistically, your application should be able to start without any flags and just do something reasonable, attached to a dev environment and just using the limited amount of resources and just not crash anything and not destroy anything. Just do some reasonable thing that is good. And I recommend to just support the run functionality. It's very rare when people actually support it. But it helps your fellow SREs a lot because they don't really have access sometimes to the code, or like they don't want to read the source code of your application, but just seeing how to run your application and what it does when you provide these fields or these fields is just so convenient. And it's useful not just for CLI commands, it's also useful for the actual applications. And keep the configuration simple in any case, regardless of flags or config files. Keep the complexity in a single place in orchestration tools. We already have a lot of complexity on Kubernetes side, or if you're using the bare metal in Ansible or Salt, we have so much complexity there. And placing the complexity in this last step of your configuration, the file that just being read once in your application, is really not the appropriate place for complexity. And do not program in configs. Sometimes it's so tempting to start implementing some complicated logic in the config itself, because we don't write tests for configs. It's much simpler to deploy configs. We don't have the same culture on developing configs as we have for developing applications, which is actually the big problem in SRE world in general. Programming applications, because they have real languages, they are much more powerful. You can do so many things with it. And yeah, keep your configuration as simple as possible. Yeah, that's really everything I want to tell you. Yeah, thank you.